Welcome back, everybody. This is section 6.1, graphing quadratic equations, and this is in that big packet that we've been working in. So far, we have focused on a couple of things. We've looked at linear equations, linear, you can see it has the word line in it, then make a straight line. So for example, that was our y equals mx plus b. Quadratic, that was way back when we were factoring. Remember that? Y equals ax squared plus bx plus c. Those are quadratics, where a, b, and c are constants, and a does not equal 0, because if a equaled 0, it would wipe out the x squared, just leaving you with a linear equation. And this is called standard form. Now we are going to look at quadratics. Okay, so we are going to label all these different pieces on the graph below. Okay, so the x-intercepts, what do you think those are? Yeah, you're familiar with those. We have x-intercept here. And the other one over here. We've also done a lot of work with y-intercepts. So that guy is here. The vertex, do you know what that is? The vertex is the highest or the lowest of your parabola. And parabola is another word. That just means your graph. Okay, so that is a parabola, that's what it's called. And your vertex is the highest or lowest point of your parabola. So there's the vertex. And what do we have left? The axis of symmetry. That is this dashed line. You can think of that as a mirror. Okay, or another way to describe it, I don't know if I can really describe it just with audio. Usually I kind of like mime this up in front of the class. I used to teach high school a really long time ago. And when I was teaching the axis of symmetry, what I would have them do is I'd have them grab a piece of paper and fold it in half, unfold it, and then I would give them paint. And I would just have them paint only one side up to where they folded. And I would have them bend it over that fold, smash it down. So it was the perfect axis of symmetry. It was that perfect mirror. Okay, it was pretty cool. So next, we are going to graph y equals negative 2x squared plus 4x minus 2. And we're going to find the vertex. So there are many ways to graph. The way that we end this class with graphing is just a very, very basic intro. So we're going to go the long way, which is just plugging in that negative 3 for x. Okay, and we're going to do that for all these. So I'll do the first one with you, and then I'll give you some time to finish them off. So I have negative 2, and then instead of x, I'm going to put negative 3 squared plus 4 times x, I said, is negative 3 minus 2. If I simplify that, I have negative 2 times 9, right? Because remember those exponents that they only apply to what is in those parentheses, right? And you would do that first in order of operations before you would multiply. So I have negative 2 times 9. Then I have 4 and negative 3. That's a minus 12 minus 2. And then I have negative 18 from the 2 times 9. Minus 12 minus 2, I get a minus 32. So what this means is that would be a point on my graph at negative 3, negative 32. Okay, go ahead and try to fill out the rest of these. I'll show the work just for the next couple, and then we'll come back in before you actually try to graph it. Okay, so once you think that you have the chart done, go ahead and check in with me, and we'll see how it's going. So go ahead and hit pause and do that. All right, so let's see how it's going. So I got negative 32, negative 18, and negative 8. And then I'm not going to write them all on here. I'm not going to make you watch all that. So I'm just going to jot them in. So you should have then gotten for 0 a negative 2, and then a 0, another negative 2, and a negative 8. And do you see where some numbers are repeating? I'm seeing it. That's because of our axis of symmetry. That's our mirror that's happening, okay? Now, if I were to just graph these guys here, do you think that would be enough to give me a pretty picture of a parabola? I think so. I don't think I'm going to get any extra benefit for making my graph go all the way down to negative 32. And I also don't feel like going to negative 18. So I'm just going to graph just this clump here. So what that means is that I have the point negative 1, negative 8. So I'm going to sketch that out. I'm going to plot that point. 0, negative 2, plot that point. 1, 0, 2, negative 2, 3, and negative 8. So go ahead and hit pause. I'll show you the top part of mine so you can kind of get an idea of like how big I made my graph, but it doesn't have to be exactly the same. So hit pause, give it a try. All you have to do is just plot the points, okay? Don't connect the dots yet. Just plot the points, come back when you're ready. All right, so I know I told you just plot the points. I just wanted to show you that when you connect them up, we don't use a straight edge anymore, okay? So we don't want straight lines from dot to dot. We want it to be a nice, smooth, rounded curve. And at the bottom, don't forget those arrows. And then finally, one last thing, I want to write in the vertex. So that's going to be your highest or lowest point. Lowest point because of those arrows, it keeps going down, down, down all the way. So the vertex is at 1, 0. Okay, so again, you want to make sure that's a nice rounded parabola. All right. Very nice. So now we're going to look at this parabola here for number 2. Use the following graph to answer the questions below. And we're going to try to see how many of these we can get. Okay, so go ahead and try as many as you like. Go ahead and try all of them. Try all of them, see how far you can get. Press play when you're ready, and then we'll come back and talk about them. All right, this first one, find y when x equals 0. So when x equals 0, what is y? So I'll go to 0 on the x-axis, and I'll go up to my parabola and see where it hits. And when x is 0, y is 3. Some people just write 3, and that's fine by me. I like to write it as an ordered pair just because it is a graph. So I'm going to put 0, 3. Next, find y when x is 4. So I'm going to go to where x is 4. I'm going to go up and find y. And it looks like that is also at 3. So again, you could just tell me that y equals 3. Or you could give me the ordered pair of 4, 3. Next, find x when y is equal to 0. So when y is equal to 0, that's that x-axis, right? So when y is equal to 0, it is at 1. And then it happens again at 3. For part D, find x when y equals 3. Okay, so we're going to go where y equals 3. So y equals 3 is here. I'm going to put in a little dashed line so you can see this dashed line is y equals 3. I'm going to see at what values is it crossing the parabola, and that's going to be what our x values are. So that's happening at 0, 3, and then it looks like it happened again at 4, 3. Find x when y equals negative 3. So I'm going to go down here to negative 3, put in a dashed line. Where is it hitting the parabola? It never does. So you can write no solution, or in your book you might see no such value. Or you also might see does not exist. Okay, for part F, it says find x when y equals -1. So when y equals -1, let me draw my dashed line at -1 so I can see where it's going to cross, and there it crossed. What is x? Right here, x is 2. So I'm going to put 2, comma, -1. All right, I'm going to switch colors here. Find the y-intercepts. You guys are so good at that. Y-intercept is where it crosses the y, so that's at 0, 3. Those x-intercepts is just where it crosses the x. So again, that was at 1, 0, and 3, 0. Find the minimum point. So the minimum, that's going to be the lowest. Okay, so the minimum, to me, that looks like 2, -1. And that minimum point is also known as what? It's also known as the vertex, right? So it's just going to be 2, -1. And that wraps up another day. Wonderful. I hope you have an amazing rest of your day.